Hello everyone, welcome to the online certification course Fundamentals of Food Process Engineering. Okay. So, this is our 11th chapter, and in this chapter we will discuss on leaching and extraction. As the topic of extraction is a very vast topic and it has a huge application in food processing industries. Many processes are there that we use extraction. Basically, it can be again divided into many different categories, in which the two phase that we mix for extraction of one particular solute or one particular component, that may vary from different combination. For example, liquid and vapor, liquid and gas, or maybe solid and liquid, liquid and liquid. So, many combinations are there, but since this NPTEL course that we have designed on fundamental aspects of food processing, there we have not included many mass transfer, in-depth mass transfer processes, for example, distillation, okay, adsorption. So, those things we have not actually included, and therefore, in the leaching and extraction we will give you an idea superficially that what are the different kinds of methods are there, what are different kind of equipments are there, and the application of this, and little bit of calculation part or some numerical problem on that, but we will not focus on to the very details of this extraction process, because for that you have to know the mass transfer process, especially distillation in a very detail, and here that is not within the scope of our course. So, therefore, I will try to give you an overview of the leaching and extraction process. So, let us start with what is the leaching and extraction process is. As I mentioned that it is separation of one or more component from a mixture by contacting it, that is the mixture, with another phase, okay, that may be solid or liquid. So, the component that we want to separate, that may be one component or maybe a mixture or more than one component, and there may be some some solute that we want to extract. Okay. So, extraction process both encompasses liquid extraction, that is called solvent extraction, and solid liquid extraction, that is called leaching. So, I have already mentioned that we are not covering here distillation or adsorption, all those techniques. Also, there are one more separation method that is, or you can say the extraction method, that is a special case which is crystallization, and another is the supercritical fluid extraction. So, if you consider leaching, so the specific difference between the leaching and solvent extraction is that in the leaching solid and liquid are coming into intimate contact, so that some solute component from the solid will be dissolve into the liquid component and will be getting separated, whereas in the extraction or specifically solvent extraction, two liquid phase are coming into contact, and then solute from one liquid will go to the other liquid, provided that the second liquid has higher affinity towards the particular solute component that we want to separate. So, in case of leaching, it is defined as the extraction of soluble constituent from solid material using a selective liquid solvent. So, what happens is that we have a chamber or extraction chamber where we put the solid which is having the solute and also have the inert solid. The solute which we want to separate, so that has to be dissolved in the particular solvent, okay, and there will be the inert solid where the solute is now mixed and that we want to separate. So, after this mixing, what will happen? The concentrated solution, that is having the solvent and solute. Why it is concentrated? Because initially the solvent will not have any solute component. So, ideally this is 0 in the initial case, or maybe very low amount of that component if it at all exists, and when all the solute will come into the solvent. So, solution become concentrated with that particular solute. So, solute plus solvent will going out, and the extracted solid, that means solute has been taken out. So, that solid will be there and some portion of the solvent will be getting mixed with the extracted solid. So, that will also be there. So, this is how the leaching process takes place. So, in this particular case, we can specifically name these two stream, one that is the concentrated solution, which is a combination of solute plus solvent, and another is the extracted solid, that is solid plus little amount of solvent, is termed as respectively overflow phase and underflow phase. Okay. Overflow, which is the solute plus solvent, and underflow, that is the solid, extracted solid plus solvent. So, if you look into the major steps in extraction process, you can categorize them into many segments. So, first is bringing the feed and the solvent into intimate contact by dispersing one phase into the other. Okay. So, the feed and the solvent you have to bring into intimate contact by dispersing one phase into the other as the droplets. So, the separation of the extract and the raffinate phase that have different density. So, this particular thing is applicable when we talk about the liquid separation, because in that case, like for leaching we are mentioning as the overflow and underflow. In case of liquid extraction, we name them extract and raffinate. Extract, that contains the solvent plus dissolved solute or the dissolved component that we want to separate, and raffinate is after extraction of the solute what liquid will remain, the initial feed slurry or feed liquid will remain. So, that is called the raffinate phase, and they have different density. So, removal and recovery of the solute from the extract phase. Now, when we have extracted, so the extract has now come from one phase to the other liquid phase, okay, and relatively pure form, because initially it was in a mixture with some other liquid, and now since the second liquid, which is our solvent, has higher affinity, that has taken, that has all the solute concentration has come into the second liquid now in a pure form. So, that we need to separate from the liquid by distillation, evaporation or crystallization. Then comes the removal and recovery of the solvent from each phase, usually by distillation. Each phase in the sense, when we perform liquid extraction, then the liquid which is used as a solvent and which is having higher affinity to a particular solute component will extract that particular component into it, and that will be coming out as an extract. Okay. And in the raffinate also some amount of the solvent will get mixed, as it was happen in case of the leaching process. So, from both the phase, solvent has to be evaporated. From the first phase, solvent or from the extract, solvent needs to be evaporated, because we want to have pure form of the solute. So, we apply distillation or evaporation, crystallization, and also that solvent has to be separated from the feed solution, because we want to have there also the initial material in a pure form, or we want to extract the solvent out of that. So, these are the things. Now, the obvious question will come that if the distillation or crystallization etc., we are doing, what is the need of extraction process then? I mean, what is the function of that? So, we can look for certain cases where extraction is beneficial over the other existing method of separation. So, these are, first one, if there is dissolved inorganic substances in organic or aqueous solution, in that case we need to apply the extraction process for separation of those components. Second is removal of contaminant present in small concentration. If very small concentration of contaminant is present and we want to separate them by distillation or such kind of method, so it will unnecessarily increase your energy consumption, right. So, then extraction is preferred. Then a high boiling component present in relatively small quantities in an aqueous waste stream. So, if high boiling component is present and very small amount, so then extraction is beneficial over other methods of separation, for example, distillation etc. And recovery of heat sensitive material. So, for them we can't apply high heat, so that the evaporation of one component will occur. So, in those cases we definitely have to use the extraction process to separate them. Okay. And because extraction is less expensive compared to the vacuum distillation. If you want to have distillation at lower temperature, so what we can do, we can lower the vacuum level in the chamber and then we can have distillation at lower temperature, but compared to that extraction will be less expensive and beneficial in such cases for heat sensitive material separation. Now, separation of close melting or close boiling liquid, where solubility differences can be exploited, and separation of mixture from azeotrophs. For these cases we definitely have to use the extraction process, because if they are close melting or close boiling liquid, distillation cannot be used to separate them. There always will be some mixture of the vapor, because they can't be separated well by distillation. So, all such cases we need to use the extraction method. Okay. So, maybe it is, as depending on the case, maybe it is the liquid extraction, or sometime we have to use the solid liquid extraction, that is called leaching. Now, we will see the application of leaching and extraction in food industry. So, the separation of sugar from sugar beet with hot water, this is very common operation of extraction and not very expensive method. Hot water can easily dissolve the sugar from the sugar beet if the cells are disrupted and it is getting mixed with the water in a proper form. So, it is very easily can be extracted. Then the extraction of oil from peanut, soybean, sunflower seed, cotton seed and halibut liver etc. So, this separation of component of oil components can be done by the extraction method. And the supercritical extraction of caffeine from coffee. So, supercritical extraction we will discuss, that is another very efficient extraction method, and caffeine from coffee is extracted by that method. Fish oil from the waste fish using organic solvent. So, organic solvent is used to extract the fish oil from the waste fish, and all these are done by the extraction. So, these are very common application in food industry. So, everyday life you use one of very common application of this leaching, which is when you use any tea, whether it is black tea or green tea bag in your morning tea. So, what we do, we take a bag and there is granulated green tea leaf is there, we dip it into the hot water and then we get the tea. So, this is actually leaching of the polyphenols into the hot water. Okay. So, this is a mechanism of leaching, very simple and easy experiment of leaching process. So, if we specifically see leaching methods, so in that these are the steps that we normally observe once we make once we bring the product, bring the solid material from which we want to extract a particular compound or particular solute. So, when that comes into contact with the solvent, solvent has to mix with that material very well and it has to penetrate or percolate through it properly, through the solid material, solid phase properly, so that the dissolution of the solute in the selective solvent will be there. We use the term selective solvent because not all the solute will have affinity in all the material. So, for that we have to select the solvent efficiently, so that it will have some affinity, higher affinity towards that particular solute. Now, once the dissolution occur, once the dissolution of solute in the solvent has been occurred, after that what will be the next step? The next step will be diffusion of solute through pores of the particle, because there will be the particle and the liquid has to enter into the pores of the solid micella or the solid particle, so that the the solute which is in the very inner core of the material will come out, will dissolve into the solvent and they will diffuse through those pores and come out to the surface. Now, once they come out to the surface, the next is transfer of the solute into the bulk solvent. Okay. So, once we have suppose we have the material, we have the micella, okay, we have the micella and there are pores through which the liquid, when the liquid is coming into direct contact with that. So, liquid has to first enter into the pores, then the solute which are in some some pockets of the material, some inner core of the material. So, they will first dissolute, they will then diffuse to the surface and they will then get mixed with the bulk liquid. Once they get mixed with the bulk liquid, so the concentration is higher in the affinity of the solid particle, whereas if the liquid is flowing, so it has to then diffuse, the material has to then diffuse to the bulk liquid, it will transfer to the bulk solvent. So, this is the whole process how the leaching takes place in a actual condition. Okay. So, therefore, what may be the factors that can influence your leaching process? So, one thing is very sure that you have to bring the material, the solid material with very good contact of the solute that of the solvent that you are using, right. So, if the surface area of the material is increased, so then only it can happen that the product will come in very good contact of the solvent. So, therefore, we have to have very fine particles, okay, so that the surface to volume ratio is enhanced. Okay. So, many times what we do, we use the granulated material to increase the extraction efficiency. So, for that particle size will be the first parameter or important parameter. So, based on the particle size, your extraction rate may vary, because the solvent has to reach in at the very inner core of the material, or it has to be in contact with the all solute components, so that it can be extracted. Next is the solvent. Selection of solvent is very important, because if you have choice of 2-3 solvent and they are in the relative order of affinity towards a particular solute. So, you have to select the higher affinity solvent, the solvent which is having higher affinity towards the particular solute component that you want to extract from the mixture. So, selection of the solvent, even you have to see the nature of the solvent, that based on your material that you want to extract. If it is a flavor compound, you have to select the solvent accordingly. If it is water soluble, you have to select the solvent as a water. So, all these factors depend on selection of the solvent. Now, temperature, how does temperature help in extraction. So, if we increase the temperature in case of an extraction process, so the temperature of the solvent is increased and it becomes, its mobility increases and its viscosity decreases. So, if because we know for the liquid, when you increase the temperature, so its viscosity decreases and then it will have more mobility and it will have more extraction rate. Now, agitation, that is, suppose there are the micella is there, the particles are there in which the solvent is coming into contact with them and extraction is taking place. Now, all the process of diffusion and dissolution and then bulk transfer is very slow unless you provide mechanical agitation to it. Okay. So, if agitation is being given in a system, so definitely extraction will be very fast, because then the portion of the material which is normally exposed to the solvent will be enhanced by this agitation. So, all the area which were not in intimate contact with the solvent will also come within the within the reach of the solvent, and the extraction will be better. Okay. So, this we have already discussed, that the smaller particle having higher, greater affinity, greater extraction, concentration, higher the concentration of the solute, higher the viscosity, lower will be the extraction rate, that is very important. And diffusivity increases with temperature as viscosity decreases, and agitation increases, so mass transfer will increase. Now, coming to the classification of leaching. So, leaching can be broadly categorized as either fixed bed leaching, moving bed leaching, or agitated. So, fixed bed leaching, that means the bed of the particle is fixed through which the solvent is passing, and within this pass, one pass or two pass like that, the material, the solute will be extracted. Now, the moving bed is that the material that has to be leached, the component has to be leached from a solid. So, that material is moving in many sections through which the solvent flow is occurring. Okay. And during this process, the leaching or extraction of a particular solute component takes place. And the third one is agitated one, in which we provide some kind of mechanical agitation for better separation. So, classification by contacting method, that is by contacting of the solute with the particulate solid, that provides three principal categories into which the leaching equipment is divided. So, first is the leaching is accomplished by rotation, which is a batch process, then it may be accomplished by percolation, and particulate solid are dispersed into a liquid and subsequently separated from it. Okay. So, that means either by rotation, which is a batch process, or by percolation and dispersion. These are the methods. Percolation and dispersion, dispersed solid leaching includes batch and continuous units. So, both the units, batch and continuous, can be observed for either percolation dominated leaching or dispersed solid leaching. Materials which disintegrate during leaching are treated in equipment of the second class, that is of the percolation leaching. Now, the rotating extractor or the batch process, what happens here? So, this extractor is actually a horizontal, as we can see. As we can see, this is a horizontal horizontally revolving cylinder is there, horizontally revolving vessel, cylindrical vessel. It is provided with a large batch for loading and unloading. Okay. So, the port for the loading of the solid. So, from here we can load it, okay, and there is a port for the discharging of the extract. So, extract discharge is also given here, and solid to be extracted, that is kept here. Okay. And there are extractant layers are given, different extractant layers are given, and also the baffles are provided. Okay. So, it is provided with a large hatch for loading and unloading the solid to be extracted, and a drain line, this is a drain line for loading the extractant and drain of the extract. Okay. So, this vessel is provided with the baffle plates perpendicular on the internal surfaces. Now, based on the percolation, again we can divide them into continuous percolator, batch percolator, and continuous can be also divided into single and multi-deck rec classifiers, bucket elevator contractor, that is called the Ballman extractor, horizontal basket percolator, that is called rotocell extractor, and belt percolator, that is called the Kennedy extractor. So, percolator and dispersion, actually in the percolation what we do is the solvent is percolated through the material, solid material, and eventually comes to the next section, and if there are more number of stages, say they will go to through all the stages, and finally we are getting the extracted product. Whereas in the dispersion, the solid particles and the solvent, they are in the proper dispersed form. So, the batch percolator, if we see, this is a batch percolator. So, here there is a loading section, there is a loading port and there is an unloading port. Okay. So, material is loaded from here and unloaded from here. We have a percolation extraction system where the spray of the solvent is from the top, and while passing through, while percolating through the bed of the particle, the extraction is being done and then it is extracted at the bottom. So, it may be recirculated sometime as with the requirement, because if we feel that with one pass all the solute extraction has not completed. So, it may be again rerun, and in that process we need to increase the temperature also by heat exchanger utilizing steam, because we know that if the viscosity decreases or the temperature increases for the solvent, it can extract more, right. So, this is the mechanism of the batch percolator. Next one is the Ballman extractor. What happens in the Ballman extractor is that, so there is a, this is the diagram of the Ballman extractor. Solid inlet is from this section. So, all the solids are coming into the buckets. There is a closed chamber of airtight chamber of all the buckets, and the solid is coming from in the bucket in a measured quantity of the solid, and extract the 50% extract that we are collecting from this left arm, extraction from the left arm, that is being spread on the top of the solids that are coming into the fresh solid, where the solute component is there in a full concentration. So, as these buckets are coming down, they will the solvent will percolate through them and the extract will collect at the bottom. Similarly, these buckets are eventually come from left to right following the path of this bucket elevator, and as it again moves upward, the fresh extractant or fresh solvent are sprayed on them. So, the 50% extract is collected from the residual solute that were there, and then again it is circulated. So, this process is continuous and all the buckets are emptied at the top of this system in a Ballman extractor and by a screw mechanism that are taken away. So, this is actually the whole systems, and all these vertical chambers they have series of perforated baskets. So, these are all series of perforated baskets in a chain conveyor, so that all the liquid, all the solvent will be percolated through them. So, there are different geometry. This is the side view of Ballman extractor. The mechanism is same as we have explained, and simultaneously the fine solid are filtered out of the solvent, so that the clean full micella can be pumped from the outlet provided at the right hand bottom, and then as this partially extracted solid rise through the left hand side, as we have seen in the figure. So, the same thing it has been mentioned that from this arm it is again going and spreading to the other arm, and then again it is coming. So, the full extract we can collect in this section. Okay. In this section we can collect the full extract. So, this is all about the Boltzmann extractor. This is a side view of that, and this already we have discussed. Okay. Next is the rotocell extractor. Rotocell extractor, this is a horizontal basket, and that is divided into walled compartment. We can see there are many compartments. So, walled compartment is there with a floor that is permeable to the liquid rotates slowly about the vertical axis. So, this is rotating slowly about a vertical axis, and that is permeable to the liquids that rotates slowly about a vertical axis. So, the liquid is coming on this small compartments, and the solid are admitted to each compartment at the feed point. So, there is a feed point where all the liquids all the solids are entered. So, this is again the schematic view of rotocell extractor. We can see there is component 1, 2, 3, 4, 5, 6 and 7, and solvent feed at from the top section everywhere the solvent feed is entering into, and there are pump to flow the material from one stage to the other. After one stage of extraction it is being thrown to the next one. So, like that, and at the end of the process from the bottom the leach solid is being collected. Okay. So, the leach solid is collected from the bottom, and solvent is entered into this section, and this the solvent plus oil that is coming, that again put into one chamber. Again the what is coming from the percolation, that is again sent to the other, and this process is going on continuously. And while this liquid is coming over the compartment, the spray of the solvent is being done, so that it can percolate and going to the bottom, and finally the leach solid will be collected. Then next is the Kennedy extractor. So, this is originally for leaching tannins from the tan bark, and it is now used for the oil seed extraction. The solid are leached in a series of tubes. We can observe here that there are series of tubes are there. Okay. And these are pushed from one to the other next in a cascade by paddle. So, there are paddles. So, that micella discharged by these paddles to the next tubes consecutively, and while the solvent flows in the counter current fashion. So, the solvent is coming from the other side. So, as the slurry is moving from the left to right, the solvent is coming from the right to left. Perforation in the paddles permit drainage of the solid between stages. So, there is a perforation, and because of that the drainage of the solid between the stages is performed. Now, another classification we can develop based on the dispersion of solid, that is continuous dispersed leaching and batch starred tanks. Continuous dispersed leaching again can be classified as vertical plate extractor, that is called Bonotto extractor, gravity sedimentation tank, that is called Dörr thickener or agitator, and the last one is the screw conveyor extractor, that is called Hildebrand extractor. So, this is called the Bonotto extractor. What happened here is that the solid comes in from the top, and there is an extract level is there, up to that it will be filled. So, there is some agitator will be constantly will agitate and make the flow of the solid from the upper section to the lower section. This bottom section is called the extraction section, and the top section, that is called the stationary plates. Then there is agitator, and the solid material flow, that is constantly from the top to the bottom. Extraction section is also given. The solvent which is in from the bottom will be sprayed to the through the material and will going from the top section. So, extract will be out from this section, where the solvent in from this section. Okay. So, while the solvent will take away all the solute from the component, the leached out solid that will come in this section and drain in the draining section, and there is a screw that will take out all the solid and will discharge all the solid to the outer section, and this is rotational movement will be given, that there is a shaft by which the whole assembly is rotated, so that the proper agitation can be given for better extraction efficiency. Then there is Hildebrand extractor. Here also the flow is almost counter current flow takes place. So, solid in from the left hopper, and then the solid is taken away by the screw conveyor to the other section, to the right section, and the solvent comes in here, and this solvent is getting mixed while it is moving towards the left. So, the liquid is moving towards the left, and then at the end the extract is taken away, and movement of the solid will goes on like this, and spent solid out from the top. Spent solid, that means all the solute has been extracted from that, and the spent solid is come out from the top section. Another operating mode we can think about, that is the extraction of either batch or in continuous mode. In batch, that is single stage, multi stage and counter current stage. So, in the single stage batch, as we have in the very beginning of this class, this chapter, we mentioned that when the feed and solvent comes into a chamber, comes into at the mixer chamber, there is proper mixing by paddles or agitators, and then settling and separation will be occur in another section, where the extract that have the solvent and the solute component will go away, and this is also called the overflow in case of leaching process, and there will be one that is having the slurry from which the solute has been extracted. So, in the terms of that solute, you can call it dilute one. This is raffinate, this is called raffinate for liquid extraction, and this is called the underflow, where the solid and little bit of solvent is present. So, that is called the underflow in case of the leaching process. Now, multi-stage batch extraction is what? In the multi-stage batch extraction, actually there are many stages, stage 1, 2, 3 like that, and in every stage solvent freshly entered. However, the feed is moving from stage 1 to stage 2, stage 3 and so on. So, in every stage some amount of liquid component, some amount of the solute component will be separated by this solvent, and they will go to the extract. So, eventually all the extract have some amount of the solute, and at the last, when the all solute component will be extracted, then the feed will convert it to the raffinate. So, this is the multi-stage batch extraction. We again call it multi-stage, but batch because this solvent is not recirculated, the solvent is entered freshly at each chamber. So, the last thing is that continuous counter current extraction. In that there are many stages, suppose up to stage 1 to stage n is there, and flow is taking place in a counter current fashion, right. So, feed is entered from one side and going as a raffinate, and solvent is entered from the other side and going as a final extract. So, this is continuous and counter current system. So, stage 1 to stage n minus 1 to stage 2 and 1, as we move, solute is extracted from the feed and getting added to the extract or getting added to the solvent. So, the extract of the first stage is entered into the stage 2, and this process continues. So, here we will stop. So, in this particular class we have discussed the different kinds of the leaching and extraction equipments and little bit application of that, and the basic process of leaching and extraction. Thank you.